Hi class, for this video, I want to review operations of functions. So you can see right here, we have product, sum, and the difference. So let's take care of the product first. S of x times t of x. So s times t of x is just s of x times t of x. And pretty much you just multiply the two functions. Straightforward. Okay, so what we have, we pretty much just distribute 3x cubed minus 6x squared. So that's the new function that we have. For subtraction, we pretty much just add them together. So 3x squared plus x minus 2. Okay. And for subtraction, because we have the values, so I always take care of the values first. So I always evaluate first, and then I use the function. So what we have, s of -1. You pretty much just plug 1 in here. So s of -1 is going to be -1 minus 2, which is -3. T of -1 is going to be 3 -1 squared, which is 3. So what I have right here is, for subtraction, is going to be -3 minus 3, which is -6. Okay, straightforward. Okay, so all of these problems are quite easy. Division, you pretty much just divide them like this. The only thing I want to remind you is, let's try the values in. So g of -5. Make sure the denominator is not 0. That's the only thing I want to remind you. So what I have is -5 plus 6. On the bottom, we have -5 plus 4, -5 plus 1. So we have 1 on top. On the bottom, I have -1 times -4, which is 4. So the answer is just 1/4. Okay, find all the values for part B, find all the values that are not in the domain. So pretty much what I just mentioned earlier, we don't want the denominator to be 0. So the values that make the bottom equal to 0 are these. So we know that we cannot have -4 and we cannot have -1. Because those 2 points, those 2 values gonna make the bottom equal to 0, and you don't want that. That's undefined for fraction. All right, so number 3 right here, you just have to, for the first one, you multiply them, and obviously we cannot simplify. So I'm just gonna leave them like that. That's the final answer right there. Now for the domain, hopefully you remember for square root, we are not allowed to have a negative number. So I know that I have to set this one greater or equal to 0, and then we just solve it. So -5/4. So x has to be greater or equal to -5/4. So we have from -5/4 to infinity. Okay, so for addition, same thing, we just add. Now in this case, we can't really add, so I just have to leave it that way. Okay, for the domain, same thing. The problem that we have is the square root. We don't have any problems with linear. For linear, the domain is all real. So I'm just gonna write down really quickly because we did it for part A. All right, number 4. Number 4 is the composite. Okay, so what I have right here is P of Q of 4. This one is Q of P of 4. Okay, so it helps if you do if you evaluate first. So let's first evaluate Q of 4. I can do down here, Q of 4. So I'm using this function, 4 plus 5. So that's going to be square root of 9, which is 3. So instead of writing Q of 4, now we have P of 3. So what's P of 3? It's just 3 squared plus 4, which is 13. Now for the other one, P of 4. So what I have for P of 4 is 4 squared plus 4, which is 16 plus 4 is 20. Okay, so instead of writing Q of P of 4, I have to write Q of 20. And what's Q of 20? You plug it in, 20 plus 5, so it's 25. Square root of 25 is just 5. And that's your final answer. Okay. All right, moving on to this problem right here. Once again, we have fraction, and then we try to find a composite g of h of x. Okay, so we take h of x, we plug it in for g. So we have 2x minus 9 plus 2. And on the bottom, I have 2x minus 9 plus 3. And for this one right here, we definitely can simplify it. So we have 2x minus 7. And then on the bottom, I have 2x minus 6. Okay, as you can see, we have fractions. So for the domain, you do not want the bottom to be 0. And the values, which makes the bottom 0, is 3. Okay, so we have to exclude that. So the domain is going to be from negative infinity to 3, union 3, infinity. That indicates we have a hole at 3. Okay, so now moving on to the one-to-one function. So recall, for function, you use the vertical line test. For the one-to-one function, you use the horizontal. Okay, so horizontal, pretty much you draw a horizontal line. You cannot cross more than once. Okay, so you see right here, I have, if I draw the horizontal line, I hit exactly 1 point. So this is a yes, okay. Every time I draw horizontal, I hit exactly 1 point. So that's a yes. This one right here, that's gonna be a problem. I hit 2 points, so no. This one, definitely a yes, right? This one, you see we hit 2 points, so it's a no. This one, same thing. So yes, it's a function, but it's not a one-to-one function. Okay. Pretty much for one-to-one function is the same y cannot share 2 different x's. Okay, so the same second coordinate cannot share, cannot have 2 different first coordinates. Okay, so that's a one-to-one definition. All right, now what we have right here is a one-to-one. They're asking you to find the inverse. So let's talk about inverse. Okay, so inverse function. A function is one-to-one if and only if it has an inverse. So the one-to-one and inverse, they go together. So you see right here, what I have is the function g. If I want to write the function, the inverse function, which is that notation, all I have to do is interchange x and y. So now I have 8, negative 9, 7, negative 4, 4, 5, and 5, 7. So what I have right here is the inverse. They're asking you what is the inverse of 5. So G inverse of 5, you're looking at this one right here. Okay, so that's gonna be 7. Okay, so don't get confused with the X and the Y because we interchange X and Y's here. Now, there's before I find the inverse, I want to make a remark. So the remark is the inverse, if you do the composite with the function and the inverse, you should get back to X. So what I mean is F inverse compose F of X is exactly the same as F compose F inverse of X, and you get back to X. So that's how we check for the inverse. All right, so how do we find inverse? This is the step to finding for finding inverse. So I have h of x equals to 2x plus 13. So first I'm gonna put a y there. Then I'm gonna interchange x and y. So instead of 2x, we have 2y. Instead of y, we have x. And then I solve for y. So I have 2y equals x minus 13. Y equals x minus 13 over 2. And that's going to be the inverse. Okay, so I repeat. First, you replace with y. Then you interchange x and y. And then you solve for y. Okay, that's it. So that's the inverse function right here. X minus 13 over 2. And if you want to check for your solution, you can just do the composite, the F compose F inverse and vice versa. And then remember earlier I mentioned the remark, we should get back to X. So if you do the inverse, the composition of the inverse, you should get back to X. So in this case, it's -4. Okay. Now, let's take a look at the square root function. So we're going to do the exact same thing to find the inverse. So first, let me just copy the problem. I then put y. Then I interchange x and y. Then I'm going to solve for y. So you see that we have to isolate y. So I'm going to have to move x over. I'm sorry, move 10 over. We take the square to cancel out the square root. So I ended up with y plus 3 equals x plus 10 squared. Now you have to move the 3 over. So that's going to be my inverse. Okay. So this is the inverse. All right. For the domain -3, this is for the function. We have the domain from -3 to infinity, because don't forget that if you have anything less than -3, that's gonna make a negative number. So we don't want that. Okay, so let's go back and think about it. Now, I have to remind you. So remark. The domain of the function is the range of the inverse. The domain of the inverse is the range of the function. So you see from the very beginning, we state that the domain is from -3 to infinity. So if you plug -3 in, you're gonna get -10. Okay, so you can see that we have for the range, we have to go from -10 to infinity. Therefore, to state the domain of the inverse, we start at -10 because that's the range of the original function. All right, moving on to number 10. So number 10, once again, we have to find the inverse. So I'm going to find the inverse. So first, I'm going to put that y right there. And then I interchange x and y. 2 minus y plus 10 equals x. So what I have is cube root of 2 minus y equals x minus 10. And then this time I have to cube it. So what I have is 2 minus y equals to x minus 10 cubed. So to solve for y, it's going to be 2 minus x minus 10 cubed. Okay. So that's going to be the inverse. Okay. Let's take a look at number 11. So 11, we have rational function. So let me just copy down here. Okay. Then I'm going to interchange x and y. Now you see that we have a fraction, so I would just get rid of the fraction by multiply the denominator up. So I'm gonna have y minus 9, and then I have x times 5y plus 6x. So I pretty much just take this and multiply it. Okay. All right, you see that we have y here and we have y here. So we're gonna have to move y to one side. So I'm gonna move y to one side. So y minus, I'm gonna put 5xy instead. I have 6x over here, and then I take the plus 9, I add it over here. So I'm gonna have plus 9 here. Okay, now what we need is we need to get y by itself. So I'm going to factor out y. And then finally, I can just divide 1 minus 5x. And there we have our inverse. Okay, now to find the domain and the range, the domain of, this is a rational function. So once again, the domain is going to be anything but values that make the bottom equal to 0. So the bottom equal to 0, I just gonna put 1 minus 5x here equal to 0. And then solving it. So x equals to 1/5. Okay, so for the domain, you do not want to see 1/5 in there. So the domain is gonna be -infinity, we goes to 1/5, union 1/5 to infinity. Now, how do I get the range of this function? The range of this function, I'm gonna go back to the original Because don't forget, the domain of the original is the range of the inverse. So you see right here, if I take 5x plus 6 and I set it equal to 0, x is going to be negative 6/5. Therefore, the range of the inverse, which is the domain of the original function, is going to be everything from negative infinity to negative 6/5 union negative 6/5 to infinity. And that's how I find the domain and the range.